So we're looking at polynomials that obviously have a greater degree. Here we're looking at one that has a degree of 5. And we are asking the question, determine if 6 is going to be a root of the following polynomial. What can we do to check? First thing we could do is we could take 6 and plug it in for every x and see if we get 0, right? But you know, that's a lot of numbers to punch into our calculator and whatever. Might have that trivial mistake. What's another method we can use? Synthetic division, very good. So let's go ahead and close up our books. Synthetic division. Determine whether or not it is a root. If it is going to be a root, what is our remainder going to be? 0. So a little review of synthetic division, what it means to be a root. We're just practicing this with a bigger polynomial. You know, what type of polynomials does synthetic division work on, or work for? Can we use it for quadratics? Sure. Can we use it for cubics? Yes. Quartics? Yes. Quintics? Yes. Degree of 6? Yes. The point I'm trying to make is you can use synthetic division no matter how big your polynomial is. And then I'll let you guys help me out from here. 6 times negative 31, which I assume negative 31 is correct. Next number is Kendra? What'd you get for this number here?
No, negative 186.
Negative 186.
86.
Okay. Clarissa, when you did the difference between those two, sorry, when you add these two numbers together, what do you get?
Negative 111.
Okay. Paige, when you multiply these two, you came up with hopefully negative 666. Okay. Wyatt, did we get this number?
1,099.
Very good. Jaden, did you get this one? And
6,599.
Is he right? No? He is? Kyler, did we get this number here? No? Dylan?
5,737.
Okay. Let's keep going. Next number, when we take it times 6. Peyton, did you get that one?
34,422.
For what? When we add those two, Montana? Is that what you were whispering over here? And what do we take when we get 6 times 11,880? Jade?
71,280.
And at this point, do we need to do any more arithmetic? No, because I know at the end of the day, this thing is not going to be 0. And if we want to answer the question, determine if 6 is a root, not a root. Once again, what does our remainder have to be? 0. So again, the whole point to example number 1 is just understanding that we can use synthetic division for any given polynomial that they give us. Okay, whether it's really small or whether it's really big. Now I do want to review one thing here. Suppose they didn't have this plus 75x to the 4th. What do we have to do then? What's that? A 1?
0.
A 0, right? Okay, because 0x to the 4th would be the same thing as not having it at all. Anything times 0 is 0. Adding 0 is simply a waste of time, so yeah, it's not there. So just make sure if you do synthetic division and they don't have one of those terms in between, you put a 0 there. If this degree is 6, how many numbers should you have listed? 7. Very good. It's always the degree plus 1 for that constant term at the very end. Okay, there's your 1. There's another one, so to speak. Example number 1 of 2. Last example. We want to find all the roots for p of x. It's given that p of x is equal to x to the 5th plus 4x to the 4th minus 10x squared minus x plus 6. Let's talk as a group real quick and then I'll let you start working on it. What is the only method that we have to solving a polynomial with degree 5? It's the one we love so much. P over Q, which is the what theorem? Rational root theorem. Okay? Tanner said P over Q. What's your P value? Yep, and your Q? 1. And how did we set this up again? Well, it was all the factors of P over all the factors of Q, right? P over Q. Factors of P are 1 and 6. Remember, we have the whole plus or minus thing going on. Let's get a little bit more space there. 2 and 3. Very good. Factors of P. Or sorry, Q. Yeah, it's 1, so the only factors of 1 are 1 in itself. So that's good news. So if we look at all the combinations, and again, it gives us the possible roots. Which include plus or minus 1, positive or negative 2, positive or negative 3, and positive or negative 6. It is now between you and your elbow partner, or a small group, whoever you want to work with, to determine what the roots are going to be. this point in the video, you can fast forward to find out what the roots are actually going to be once you figure them out on your own.
Let's see.
Here's some good ideas. Some people are trying this route, others are trying a different one. I would definitely go that route.
Two. Zero in there for the, because there's no X to the thing. And then do you want to try positive one, I'll try negative one, I'll try one. I'll start with negative.
According to the fundamental theorem of arithmetic, how many roots should you come up with?
5.
Should come up with 5. Is that necessarily going to be the case? No. What do we use to explain that? Starts with an M. There you go.
Yeah, so it's negative 1, so you gotta put it.
Can I move?
No, you can.
Oh, come in.
Right, it's a rock, he's tested it, and you got to use this one.
Okay. You can either then stick with the numbers that we have up on the board, or you can use the new ones that you see on the board.
You can leave the next word. And then use that.
Yeah. The only method that we really have to work with goes with what highest degree. Degree of 2, right? We know how to solve a quadratic. We could either use quadratic formula or we know how to factor. So after you get the first one, yeah, now you're down to a degree of 4, which means, okay, we're going to have to do synthetic division again. You can either use the numbers that we have up there, or you can use the new numbers that you generated. Make sense? If you use the new numbers, that's one less number that you have to do, because you just eliminated one of your terms. What's the problem with the numbers that I have up on the board? Yeah, I need a 0 in there, don't I? 0 between the 4 and negative 10. Good catch. Keep going. I want you to come up with all the roots. Yes.
1, 5.
I bet more than one works. 1 and negative 1? Yeah. I bet others work.
So I just plug in right now.
Well, go back to your list. Did you try positive 2? Did you try negative 2?
I think we tried negative 2.
No.
Try the negatives as well.
If you have an English, plug in more possible, you say.
Yep. Yeah, you can try some more negatives.
Well, technically 4.
That'd be negative 2. I'll do negative 2.
Once you feel you have all the roots, go back and see if you can identify the multiplicity of each root. Because you don't have x to the third, therefore you get 0. Try to put that one.
What would you use for x to 0? Yeah. So you got 2. Did you work? Yeah, you do. This will be next. Should we get 3 again? Yeah. Negative 3, so it's 1 unit. Negative 3. No, because I know you got it. Yeah, that's our. Right.
See what that's, is that a test? Teachers get on YouTube. He said not like wrong. He's in true. So 92.
How many roots have we come up with?
2.
2? Tanner has 5? 4? How many roots did you come up with?
I'm assuming 60. Huh? Well, I just broke this my class. Let's keep flipping. Hey, you try 6 and you can do the alternatives.
No.
I think we can use it.
So you might as well make it 3, right?
No.
Don't want to break the streak.
Yeah,
No,
we use
this is the
them.
one street. Yeah, this is the one street. Look at this, two street.
I got 1.
I quit.
-1.
Yes, I'm like, I can't remember. There's streaks, and I'm just like, anyways, like this one chick enemy, and I was like, who is this? And then she's gonna be
Give you a little bit more time to see if you can come up with them. Did you get them all? Which ones do you have so far?
-1.
Did you try 6?
I took put negative in that, it didn't work.
like, I haven't.
Sure.
Try to do that.
Negative 32.
You got
No.
You got it.
One parentheses around it. Oh, you're saying wait, negative 2 to the 5th?
I put a picture of everything. When I was looking at it, I was chilling at the fix once, had everything. It was it took me like 20 minutes to take. It's like a silhouette picture.
You're right.
I put up a 20 minutes to take a picture, and then I took a picture of him, right? And then I got so many, right? So many people. One of them was from Kyrie. I was just like. No, I'm gonna like maybe
I think we're at the point where we want to go ahead and finish with this. What's a number you would like me to start with? One of the possible roots. One? Alright, let's start with 1. Could I have started with -2?
Yeah.
Let's see what happens. -2, 2, -4, -4. I get a product of 8. That's a difference of 2. That's a product of 4. That is a difference of 3. And that's a product of -6. Wouldn't you know it, -2 works. Okay? So down at the very end, roots, -2. Now, you could have just stayed with those numbers 1, 4, 0, -10, -1, and 6. Or at this point, we know this. -2 was a root, correct? So going from our degree of 5 polynomial, we now have this. X plus 2, because -2 is a root, and whatever's left over is what is left over when you factor x plus 2 away from that polynomial. See, our constant term x, x squared, x to the third, x to the fourth. So what's left over is x to the fourth plus 2x cubed minus 4x squared minus 2x plus 3. Does that make sense? That's the nice thing about synthetic division, is because synthetic division, if you use these numbers, starts breaking these down. So at this point now I'm going to go ahead and use these numbers. 1, 2, -4, -2, and 3. What's a number another number you would like me to use? -3. Let's see if it works. 1, -3, -1, 3, -1, 3, 1, -3. And wouldn't you know, there it works again. So now we had x plus 2. Now we get to add the x plus 3. What's left over? Constant term, x, x squared, x to the third. And I'm going to keep going so you see how this thing unravels. Next numbers we get to use are 1, -1, -1, and 1. And again, we would go back to our list. Which one of these 8 do you want me to use? 1? 1, 1, 0, 0, -1, -1, 0. Sure enough, that works. So, we have the x plus 2, x plus 3. What would this be now? X minus 1. And what's left over? Constant term, x, x squared, x squared. We don't have the middle term, minus 1. And lastly, we're down to our degree of 2, so we're going to factor this thing if we can, so we don't have to do that silly synthetic division again. Does this thing factor? Yes or no? Does x squared minus 1, does that factor? Yes. What does it factor to?
X plus 1,
Mm-hmm. You're right. So we had -2, -3, 1, -1, and 1. So for your answers, your roots are -2, -3, 1, -1, in any given order. What was the multiplicity of -2? Multiplicity of -3? Multiplicity of -1? 1, multiplicity of 1, 2. And what should all of your multiplicities add up to? Your degree of 5. So, we started with the polynomial degree 5. We ended up finding 4 real roots, which meant one of those had to have a multiplicity of 2.
No.